Hello everyone, welcome to 6.7 Polar Coordinates. It's a new type of coordinate system, and there's really only two parts, and it's actually pretty straightforward if you think about it logically. It's how far out does something go, and what is the degree at which it is. So if you were to ask someone, or if someone were to ask you, where's the ball? You would say, it's over there, or it's over there, or it's over there. And you would tell the degree, and then about how far it would be. It's over there about 10 feet. It's over there 6 miles. Whatever. Alright, exact same idea with polar coordinates. So here's what a polar coordinate graph looks like. It looks very different than a Cartesian coordinate or an XY coordinate, rectangular coordinate sometimes they're called. But the origin you could still say is this center part, which is called the pole. But then you just basically make concentric rings, and then each one is a different radius. So a radius of 1, radius of 2, radius of 3, radius 4, radius 5, radius 6, radius 7. And then it has each angle going out as far out as our largest radius. Alright, fairly straightforward. So let's look at a couple of things. So for example, let's look at plotting points on a polar system. So for example, if we want to plot 2 pi over 3, we would just go here and say we want to go 2 out. So we go 1, 2, right? Let's use red. Let's go 1, 2, and we want to go to pi over 3, which would be the normal pi over 3 spot that you would find in your unit circle. So right there, that is really small. Let's make it a little bit bigger and say 2 pi over 3 would be right there, right? It's like going out 2 radius, right? 1, 2, and then pi over 3. So that'd be really easy. Let's look at the next one. The next one is 3 negative pi over 6. So I'm going to go out 1, 2, 3, and negative pi over 6 is going down 1 pi over 6. So we ended up at 11 pi over 6. So we'd be there. Not bad. And then the last one, let's plot negative 2 pi over 2. Alright, so what we're going to do is I would first go to pi over 2, and I want to go from this line right here, I want to go negative 2. So I'm going to start at the pole and go down 1, 2. So that would be our new spot. Notice how positive 2 would be up here in the pi over 2 direction. But because we're going negative, we're going away from pi over 2, and it's going to start at that middle. Alright, there we go. So here's example 1. Plot the point 3 negative pi over 3 and find 3 additional polar representations using once around the circle from negative 2 pi to 2 pi. Alright, so we want to go from 3, negative 3 pi over 4. So I'm going to use a different color. Let's use blue. And we're going to go 3, which would be out here. And we want to go negative 3 pi over 4. Well, 3 pi over 4 normally would be right here. So if we're going to go in the negative direction, we're going to do the same thing but in reverse. So we're going to go down here, that'd be 5 pi over 4, and we're going to go 1, 2, 3, and it is a positive 3, so I would plot my point right there. So let's see if we can name some other ways to do it. So the first thing I would do is let's make the radius still 3, and let's make the degrees the positive. Alright, so we'd still say this could be the point 3, comma, and then what was our degrees, or our radians, was 5 pi over 4. So 3, 5 pi over 4. There'd be one. Okay. Another one could be if we were to make it pi over 4, but then go negative 3. So we could start on this angle and go negative 3. 1, 2, 3. So we could say it would be negative 3, comma, pi over 4. Alright, and the last one we'll do it is to go all the way around the degrees negative, or the radians negative this way, and still keep the negative 3. So negative pi over 4 would be the same as going that way, but in the negative direction would be the same as going 7 pi over 4 in the opposite direction. So we could also say this would be negative 3, comma, negative 7 pi over 4. And there would be our 1, 2, 3 different representations. So we can represent one point 3 or 4 different ways, rather than in the rectangular coordinates of only having it one way. You go negative 5, negative 2. You always know you go left 5, down 2. Alright, so let's convert rectangular to polar, or polar to rectangular. We can go back and forth, so it doesn't mean just this way. We can go polar to rectangular, rectangular to polar. If you have xy, it's the same as r cosine theta, and y is r sine theta. We could also write tangent theta as y over x. So that means if you know what y and x are, you can go back through and find theta, and you know r is going to be x squared plus y squared. Kind of just like the unit circle, except no longer is the unit circle radius 1. It can be anything. So let's use that to do a couple more examples. So example 2, convert the points to rectangular coordinates, 2 and pi. If we just graph this real quick, you get an idea of where that should be. So I'm going to go to 2 and pi. So I'm going to go 2 in the pi direction. That would be right here at this spot. So it should be, if you think about a normal xy coordinate, this would be 0, negative 1, negative 2 in the x, and 0. So my answer should be negative 2, comma 0. That's what I think it should be. Now let's actually use this to see if we can figure it out. Alright, so I know that x, there we go, we'll get it eventually. We know that x is going to equal our cosine theta. There we go. So we know x is going to equal, r is 2, and we're going to say cosine pi. Then we can say y equals 2 sine pi. Alright, so cosine pi is negative 1, so we can say x equals 2 times negative 1, so x equals negative 2. And we can say y equals 2 times sine of pi is 0, so we can say y equals 0. So our point would be negative 2 comma 0, which is what we thought when we graphed it. Perfect. Alright, good. So example 3, convert points this point to polar. So now we have regular, rectangular, or Cartesian. Now let's get it back to polar. So I know that tangent theta is going to equal, it's going to equal y over x. So let's make it y over x. Y is 1 over negative 1. And then we know that r is going to equal negative 1 squared plus 1 squared. So 1 plus 1 is 2. And then it's going to be r squared. So r equals square root of 2. Okay, so tangent theta, 1 over negative 1, that's just going to equal negative 1. So the inverse tangent of negative 1 is 3 pi over 4. So tangent, or just theta, is going to equal 3 pi over 4. If you don't believe me, you can look it up. You can use your calculator. You can pause. You can find that out. Very good. So then we could say this point would be, and it's r comma theta, is how you write the point in polar form. So it would be square root of 2 comma 3 pi over 4. And there you go. So here's your assignment. Convert square root of 3 comma pi over 6 to rectangular coordinates, and then convert the point 0, 2 to polar coordinates. All right? Good luck.